Nobody asked for another podcast, so here you go. This is yet another Infra podcast.
Hi, everyone, and welcome to our third episode of yet another Infra podcast. In this episode, we're joined by three wonderful guests: Yoko Li from A16Z, Rajko Radovanović from NEA, and Steve Kamman from King Alpha. We have great topics for you today, including how the cloud is like airlines, how frontend is really infra, and the challenges with deep tech startups. Hope you enjoy. Steve, you recently posted on the server about basically equating the cloud to an airline, and you came up with your cloud as an airline metaphor. Can you elaborate a little bit on that? What do you mean when you say that the cloud infra providers are similar to airlines?
Yeah, and my background, I'm an investor. So I think about business models, and I'm a public markets investor. I just think about business models and try and understand the technology, but I come from that side of the equation, the economics of it all. So the thing about cloud, and for people to understand airlines, is it is a combination of really high capital expenditure and then just capacity utilization. And an airline that flies with all the seats full makes a ton of money. An airline that flies with no seats full makes zero money, but their costs are largely the same. And the same thing's true for AWS, or I'm going to use AWS pretty much for cloud here. If everybody turns off their workloads tomorrow, AWS's power bill goes down slightly, and otherwise they have to keep paying absolutely everything. Same side, if they're running at absolutely 100% capacity, the thing is blowing money out the door. Key thing being that their fixed costs are almost all of the business, their variable costs are almost none of the business. And you say that and it sounds fairly vague, but everybody's dealt with an airline. So that was where the metaphor goes.
I'll chime in that we'll know cloud has really hit rock bottom when they start double booking EC2 instances and offering you vouchers to give up your EC2 instance at peak load times.
Because they actually do that.
When you sell tickets, purposefully you sell the same ticket in the same plane twice and expect one person not to show up.
No, and seriously, it's that if you're smart, an airline sells the plane to 110% capacity and assumes 10 people don't show up. I'm making that number up. And that depends on time of day and et cetera. But there's always some people who are late or grandma kids. So, but then apply that to a cloud context. So what an airline wants to do is sell all of its seats. And if a plane flies with an empty seat, that seat will never generate a dime of revenue. And that's the only other element in the equation is there's a time element to it, which is I have to sell it today. So if I sell that seat for $2, it's $2 I otherwise wouldn't make. The second thing, and this is where I'll flip the cloud a little bit here, is like double booking, is I want to sell reserve capacity to a bunch of people. Then I want to sell spot capacity to a bunch of people because, and this is somebody's data point, is actual usage on that reserve capacity is like 10% on the CPU, meaning 90% of it is sitting there already paid for, which is awesome. Somebody paid for the seat, and then I can go sell the seat multiple times over to multiple different people. Then there's going to and that's just overbooking bin packing. Then there's another layer, which is spot instances, which is, hey, I happen to have a little bit of extra workload here, planes flying. That's like people standing, remember standby. And eventually there's a crowd of people standing in front of the gate saying, can I please get on this plane? Hey, we got 5 seats, whoosh, get you on the plane. All of that logic is the thing to think about from the economics of cloud. And it's one reason I think they keep pushing price down is what they're trying to do is resell the same infrastructure over and over and over again and find more and more creative ways to slice and dice that without, to your point, actually leaving pissed off people holding vouchers when they need to get on the plane. And or per spot instances, you bought a really cheap ticket, that meant we could bump you. You know that, I know that. And that's, as long as that's part of the contract, everybody's happy. So the thing where I was trying to go at with that is, one, that's their economics. And so every time you think about a cloud, you should think about an airline. But two, it so speaks to why people think the clouds are going to be double subsidizing or they're doing funny things with their numbers and or raising prices. So the prices haven't gone down. The whole thing is, look, the more ways I can slice and dice this and the more cheap ways that I can come up with selling you anything that isn't a reserved instance or isn't just a standard bucket. All of that basically always translates to how can I sell you the same thing for more? And the metaphor I used there was it's like a first class airline seat. Okay, they're a little wider, but broadly speaking, it costs just as much to fly somebody in first class, plus a few extra drinks and a not very good meal. It's first class, and especially on transatlantic flights, will just pay for the whole damn plane. Economy essentially flies free. And that's beautiful from it. And so then the beauty of a cloud versus an airline is they can change their first class to economy mix pretty much instantly. And what you're then doing is so then you also look at their economics. It's, I'll sell enough to pay the bills and then look for as many creative ways that I can sell the back of the plane for as tiny an amount of money as possible.
I think it was Peter Thiel who famously in his 0 to 1 book mentioned that airlines is like the worst market you can go after, because if you take the sum of all profits ever generated in this industry, you will get zero. How do you think about cloud? Because it seems like almost quite the opposite, in at least in what we're seeing.
It's actually, so the other thought I would put, I'll throw in another part of the metaphor because it works for people, is especially if you've ever flown Southwest, who I love because it's the only halfway functional airline out there, but they turn the planes around every 30 minutes. And you and I know that their dream in life is to somehow find a way to hand the gate agents cattle prods, is get everybody on and off in 15 minutes. Because a plane on the ground is making no money and a plane in the air is making money. And the problem is there are these annoying people things you have to get on and off the plane, and baggage things to get on and off the plane. So you have to stop and put it on the ground. If you then, and so again, think then from a cloud perspective, I think this is why AWS exists. Because the airline model is I have to staff up for Christmas and Thanksgiving and a couple of other things. And I need enough physical planes flying around the country to cover those peaks. And the rest of the year, I'm like, I got these planes. I got to do something. So you think back to Amazon's days, what's the worst business in the world? Running an e-commerce site with dedicated infrastructure. Because I'm staffed up. I've got all the servers I need for Christmas. And Lord God, what do I do with these things come middle of January? So, well, I'll sell them to other people. And that's where it's different. Or if you were to imagine the airline industry, imagine if all the airlines got together and shared one single pool of, then I could fly the planes over to China for, was it Golden Week? Start to see where maybe I could at least get some capacity utilization advantages. And this is where compute is obviously very different from planes because they're not big physical objects that consume fuel. But that model is where you see where cloud came from in the first place. Now I'm looking to manage everybody's peaks and valleys across a global context. It also says why scale is, and this was an Amazon presentation a while ago. This guy rattled off a bunch of names of apps that I'd never heard of, nobody in the room had heard of. He said, these are the most powerful gaming apps in Nigeria. And the thing that you don't understand is that when you're asleep, these are all running on AWS East. And the beauty of it is then when you wake up, the Nigerians are asleep and we're using that same compute to run your game. That's where you escape that kind of airline nightmare, because their problem is they can't they can't generate enough excess traffic outside of Christmas and Thanksgiving to handle that. Plus, there are these squishy human things that are tough to get on and off the planes. The beauty of compute is you can just abuse the hell out of it and nobody seems to care. The code does not feel bad.
I feel like the analogy is a good one, but it does feel like the cloud market is a lot more efficient than airlines in the sense that for airlines, you get on and off, you can't resell. But as we've seen, there's a very robust secondary market that needs extra tooling to autopilot to manage on the instances. Hey, I bought some instances for some time. How do I resell it? And then you can even resell it like minutes or when you are using it, when you shut it down. So that's where it's interesting. Like right now, it's more popular on the EC2 side, but I have no doubt it will happen for other kind of resources too. So with Airline, where you're in the air, you can't really get off. And then when you're standby, you can't really resell that seat. So that's a part. And like the AWS or other cloud, the interesting part is that it's like a free market in that you can do very high frequency trading, like basically on these resources, and then level them, distribute them in different regions, in different workloads, like for different kind of people who are utilizing them. So that's where I'm like, it is definitely a much better business than what Airline is, and the margins quite fixed.
Yeah, that makes, I actually didn't know the secondary market was that robust. So that's, the other thing I'd add is, to your point, Rajko, the larger your capacity size gets, the more that your peaks and valleys damp down, just probabilities. And so this is also where it's a scale game. Is the bigger you get to a place where I'll say it's where you get to the, well, sir, I'm sorry, we can't get you to Pittsburgh on a direct flight, but we'll fly you there via Mumbai, which a normal human is going to be like, no, that's not cool. The code is going to, all right, fine. And realistically, all right, it's a really ugly network hairpin, but it's not that big a deal. The capacity always exists somewhere. And the problem is how far you have to go. Cloudflare is another kind of similar example where they have this huge free tier. And the essential argument is, the essential pitch is, hey, we may serve your stuff from halfway across the world because you're in the free tier, but there's always space for it to be served from somewhere. The other place I'd go with that I like the metaphor, is imagine if Southwest started building its own planes. And so you think about Southwest fantasy plane is that they can load people like baggage. And I was like, they'd shove everybody into these little pods, like amusement park pods, close them up, and then load all the pods on the plane in 5 minutes. It'd be like a little conveyor belt that would just go straight onto the plane. And then they could turn the whole thing around in 15 minutes and add that many more flights per day, make a lot of money. You can imagine the Southwest Airlines fantasy here. The difference between Southwest doesn't make planes and never will, but all of the clouds are starting to build their own hardware. Again, AWS much further down there. And so things like, if you build your own CPU and SE and things like this, I can start to reduce, or more importantly, get a better sense of reliability on wait times. So where a CPU is sitting there waiting for something to come out from storage, it's idle. So great, I'll just use that. I'll go scavenge that time. The customer doesn't know it's there. And as long as if I can shorten that time and or reduce the variability of that time, then there's that much more CPU I can scavenge. And the thing about the model on the scale side, that is any individual enterprise probably sees that opportunity. And if they worked really hard and did it, they would save 50 cents a year. But in the metaphor I used, I think it's not true, but some English guy apparently stole 2 cents from everybody and sent it off to his bank account. And there was a legal loophole where nobody cared enough to sue him or press charges, so he got away with it. If you have a large enough number of bank accounts, you can, what's the word I'm looking for? You can get a hell of a lot of money out of it as long as you have enough scale. So that it's the idea of, look, if I vertically integrate, I can suddenly realize efficiencies I cannot realize at a smaller scale. End of brand.
Awesome. Well, thank you. That was a great topic. But let's switch gears to another topic that actually is a little bit of a misunderstanding about the kind of a infrastructure server, is that infrastructure is just about, let's say, hardware, compute fabric, container orchestration, frameworks. But actually, Yoko, you've been trying to get some love for front end and JavaScript and all of those kind of things as well as part of the group. And it seems like there's actually a lot of people that all of that technology resonates with. Can you please tell us why do you think this is also a great innovation happens in that space, and how does it relates to infrastructure, and why do you love JavaScript and the ecosystem so much?
Thank you for that. It is interesting when we talk about infrastructure, we always think about containers, EC2 servers. I used to write server monitoring software at AppDynamics, so I was familiar with that world. I also wrote a lot of JavaScript as a JavaScript developer, and I realized that the word infrastructure, how we see it, it's basically anything that powers the application. Like, for example, you need API as a service for your app to run. That's infrastructure for application. Like, you need a platform for your front end to run, you need a platform to power your CDN, things like that. So I think my bull case for the JavaScript world is that as someone who went to school studying computer science, this is a story I really love sharing with folks who are like Infra or JS maxis. So back in the days, the first language we learned was Java and C, and then we moved down to the hype of the era, which is Ruby and Python. It was like the cool tech of the era. And then some people will say that's low code. It's not a real programming language because you don't do some low level programming. And one time I ran into this person, and then when I was in college studying CS, the person asked me, so why don't you study socket programming? And I thought, why do I need to do that? I just call an API. Why do I need to do the low level open a socket and communicate with the server? And years from that time, now I feel the same way about JavaScript, in that now all the new engineers I meet, all the boot campers and all the folks who went to college, if they take a job writing applications, the chances are they're going to use JavaScript, not just for the front end, the UI part, which is actually very complex, but also for the middleware and then for communicating directly with databases, thanks to the database tech that's now very mature to support that. So now when I talk to this audience, the question I always get is that, hey, why do you need to call an API? I just use a React component. So to me, that's like the shift in abstraction, in that what's the interface programmers are now using to communicate and get the data to get their programs to work. The interesting part for me is that JavaScript now, although we have a front-end channel, I create a JavaScript channel. JavaScript is so much more than front-end. As someone who's from a very infra background, like I was a product lead on Terraform Cloud, you can, it's like a very low level provision instances kind of a thing. I'm seeing that more and more people are provisioning upper level, like up on the stack kind of infrastructure to power the apps directly. And they can write JavaScript on it. So things like Vercel and Neverify, you don't need to know all the other technical details. You just need to focus on the business logic. And then for the state, there's workflow engines to manage that for you. Stately, Temporal, Orchis, all the great companies there. And then for the backend slash databases, you use LTP, things like Convex, things like Chisel Strike. So I guess my point is that now I think we're at a platform shift. It happens once every 10 years, 10 to 15 years, that there's a new wave of new blood in the building things in a different tech stack using a new technology. And I'm just always curious what's the new set of tech that's going to come out to support that.
Awesome. Thank you, folks, for joining the last episode of the Yet Another Infrastructure podcast. We have just been canceled for not liking sockets and writing streams of bytes into them. Joke aside, so Rajko, what are your thoughts about the JavaScript ecosystem and what Yoko just shared with us?
I love it and fully agree. I will say high level of kind of side project that I've had that I want to do, but haven't got into quite yet, is just looking at the largest technology companies that emerged pretty much in every decade. And I think if you plotted that out for the last 50 years or so, and you classified them by where they sit in the stack, you'd get a very neat chart going from down to up. And I think just like cloud abstracted, you don't really have network engineers in that many enterprises anymore. You do, but it's a declining number of people and companies. Certain layers of the stack can get abstracted over time. And honestly, it's part of what excites me and what I like about technology, right? Like it's what makes the innovation compound every 5 to 10 years. The fact that, I'm going to not talk about JavaScript per se, but just the idea of abstraction and what it allows. The idea that GPT-3 could have been launched in summer 2020, and then you have 400 startups actually building products on top of GPT-3, thanks to cloud technologies, the fact that you can access it with an API, immediately build on top of it and launch a product, that to me is crazy, right? Like that completely would have been unfathomable 30 years ago. You would have had to physically buy hardware. Somebody would have to manufacture it. The cycle times would have been significantly. So I don't know. I completely agree with Yoko. I personally spend a bit less time in the JavaScript and front-end ecosystem. I come from a data background and a lot of Python and data science and that kind of stuff. But I envy her ability to focus on a new and exciting and emerging space. I think it's super cool. I think she's on point. Makes total sense.
I'll have a hot take. NPM is so much better than Python's package management.
I completely agree, because Python package is all I know, and I despise it. Like literally every time I'm setting up a new environment, it's 3 hours of why I want this run on this laptop and do. Anyways,
I've got a question. What about the sort of Heroku 2.0 problem of the thing I've heard about? Because I love all these Vercel's net, but the idea of, yeah, that's great for toy projects, but then if you, and maybe a lot of stuff just never scales, but if it does scale, you're left with this incomprehensible hairball that you can't hand to a backend team to optimize, and you basically have to start over again. So that's the question. How does that evolve in such a way that this stuff does actually become industrial use and or scale up gracefully?
We already see personally, this is like a research subject when I was a PM, just doing a lot of infra stuff. So we're already seeing more. So Heroku, sadly, is not in a good state right now, but previously it went up to a lot of enterprises, and so far that there are very big companies using it. So for a majority of the world, I would say graduation risk is not a problem until you're the G2K. Then it might be a problem for you. But then even then, I don't think it's all or nothing in that you can have a deployment platform like Railway, like Heroku, things like that, but then also have this escape latch to plug into the broader ecosystem that the G2K, like Zika Tech, the ecosystem demands. So I would say it's more like a technical detail on how to make that happen and how to find the right abstraction and open up the right knobs. for that to work for the enterprise customers, I do think it's very possible. It's just like folks will need to they keep iterating on the tools, and I do believe it will happen.
Yeah, so I'll add a little bit of my point, given my background at Salesforce, which currently owns Heroku. You're right. There are many large customers that are using Heroku. They're actually using it in a very different way, I would say, than we would think about a Silicon Valley tech company would be using it. Many of them actually use it in order to customize their Salesforce instance. So there is a lot of revenue that comes for this way, but also in many of them, they might have think about a mobile app that is somewhat self-contained, and that actually Heroku might be perfect for. You don't need much more than a Postgres and maybe a Redis and kind of things like that. But it's probably will be hard to build like the next Google on Heroku. So there is certainly a graduation issue. But Steve, I think that now also with the kind of advance in the kind of JavaScript ecosystem and what we see with Vercel and Netlify, I think the realization is comparing, let's say, Heroku to AWS is, to me, is a little bit akin like comparing SQL to a general purpose language. Like you just use SQL for whatever it's great at. You just using a C+ or Java for that is a complete overkill, and it actually makes you less productive. And there are definitely a family of use cases that I think all of these mini clouds, let's call them, are perfect for, and a lot of people use them that way.
One analogy or thing that I like to throw out for people that are both technical but also have a bit of an economic background is you can think about abstraction and technology and whether or not higher level abstractions are sufficient for what share of the market. Because I think as you're describing, Vitaly, there's always like a distribution of the market in terms of how high performant the needs are of different people. And then you come up with one solution and it'll cover up to a certain point, and then won't maybe cover the top of that market. I like to think there's supply of technology and how competent and the existing technology in the market is today and how fast it's progressing. And then there's the demand curve of the use cases that we're actually using in the real world. And I think it is a little interesting in the last 20 to 30 years, if you think about the infrastructure market, the emergence of the World Wide Web created an unprecedented spike on the demand side of the use cases, right? All of a sudden, an average person from their home could launch a website that if it took off would need to scale to millions of people in like unprecedented timelines and speed. And pretty much every single run-of-the-mill company could do the same or might need to do the same. And I think I'm actually not sure that's still happening or is the case. I think the world is globally connected. We have the marketplaces have emerged. They'll continue to emerge. So I kind of view I think the demands, there are new areas of increasing demand on technical needs such as AI and ML, as we can see with these really large language models. I don't think they're as broadly applicable as I want to set up a website to sell something to the world, at least not yet today. So I think we're in a little bit of a stagnant period on the demand side. And on the flip side, the supply continues to increase. Like people continue to innovate and improve performance, and there's no shortage of that. So I really do think we might go from an era of people innovating on really deep systems levels purely for performance and a bit of a shift towards people innovating and delivering value to builders through ease of use, through abstraction, et cetera, et cetera. So yeah, that's like the very, very high level. And then on a more granular level, I also think some of these players like Heroku and such, the DevOps environment has never been as uniform, as interoperable, and as unified as it is today. And I think that creates a really big opportunity for those escape hatches to actually work. Heroku had Ruby on Rails, but that was just one framework. And the moment you were out of it, it fell apart. I think some of the new players that we're seeing, like using mixed packages and other things, kind of like Railway does, it's a much more interoperable DevOps environment than it ever was before, and that creates opportunities too.
The only I'd offer, and I think it's what you were saying, is I think my biggest realization for this last year is most stuff never goes to Google scale. There's no reason to build it to Google scale, and there's an insane amount of volume. But the amount of insect life in the world is like massively outweighs all mammal life. It's just very small. And so that was a big insight for me, and that might actually be the answer to your point. I just figured I'd share that thought.
Yeah, absolutely. You are correct. And I think that at least some of us here are based in Silicon Valley, and the only kind of application we can imagine is like Google or Facebook scale. But you're absolutely correct that most applications might be much smaller and still actually be very decent businesses. Like one also example that I always like to point out while I was at Salesforce, that the initial Salesforce application were basically kind of Oracle with a JBoss server on top of it, and that reached billions of annual revenue without any flares. And now, Rajko, like you said, like it seems like there are new websites that get started that only kind of your parents know about, and it's already has 20 items in the stack in order to build them. And I think somewhere there we kind of lost the script on building technology.
Yeah, to that point, I think another exciting part of JavaScript is that this is originally Alex's plan. Sadly, he can't make it today. Hi, Alex. But one point he made, I really agree, is that JavaScript is such a good language for driving compute. So the way to think about it is that if you're just operating server box EC2, you can be very economical about it and fine-tune the shit out of it. And then as you go higher on the stack, you're like, oh, I'm writing application logic, business logic, things like that. So that means the higher up the stack, the better it is to drive the consumption of the lower level compute instances. And JavaScript happens to be the language, lingua franca, of the highest level of the abstraction right now. Maybe you can argue that, oh, maybe that component is even higher level, this is a framework. But it is interesting to margin will play out based on if the majority of the world, the newcomers, because the Infra never dies for legacy players out there. If all the greenfield projects are just going to be started on JavaScript using the already made services, what kind of margin does that play out for the service providers? And does that mean that we are facing a better margin just because everyone's utilizing that service and not buying into the whole stack?
Awesome. Thanks again for joining us. Then we have this kind of unique episode where we have three kind of VCs or research analysts here. So I would like actually to take this opportunity to talk a little bit about kind of markets and then opportunities, especially for, let's say, startup. One of the observation I had about a lot of the startups in the machine learning space, or it can be generalized a little bit to deeper tech, is there is this issue that there is a very small market for that really understands what you're doing. I'm talking about things that are like hyperparameter optimization, vector databases, and all of that. And it seems like within that market of the companies that need that lower level of kind of components and can just use the primitive that large cloud providers provide, all of them are already big players that probably have a solution in the field. So it seems like the Venn diagram of people who understand what you're selling and people who actually don't already have a solution themselves is fairly small. So from the standpoint of an investor, like how do you think about those opportunities where companies in that space present themselves to you?
I'll say this. I do think there's a really common pattern, especially among venture capitalists in Silicon Valley, to try and look at emerging technologies and tooling at some of the largest and leading tech companies, and then evaluate whether there's potential to spin up independent companies and actually bring value with those tools to the rest of the world. I broadly tend to think that there's three different types of ways that these new technologies can emerge in these really large tech companies. The first is probably when those tech companies purely hit scale that nobody else had ever hit before, and then create systems that solve that challenge. I think we had a really big wave of that, what we just discussed. And when it's purely performance related scale. And actually, I think that was a very good thing to invest in, probably still is, but maybe tapering off, TBD, that's a hot take. The other is sometimes they also create systems that try to solve like more organizational problems for people. And there I tend to be a bit more of a skeptic because, and I'll just give one example. I won't name names of technologies or companies, but for example, there was a big effort to create better metadata management / data catalog solutions out of some of the really large tech firms that emerged in like the 2010s. And in-house, they built really complex solutions from an infrastructure perspective, like these things that were running on event-driven systems, like distributed-driven systems like Kafka, so that they could ingest all the data, metadata, so that you could query it. And then they had really advanced technical interfaces for very sophisticated technical users to create advanced queries and figure out what's happening across an organization of 10,000 people and how they're working with data. On the flip side, you had some companies that emerged completely not out of the large Silicon Valley tech companies and created what I would call like GUI, SMB-ish, nice to use, neat tools to help organize medium-sized data teams. And you also have a whole third group of players that are more traditional enterprise services-based go-to-market. They will come, custom implement everything, train your team how to use it. Out of those three groups, the big tech, the SMB, and the enterprise services, I actually kind of think the SMB and the enterprise services are doing a bit better. And I think it was a bit of a fail VC investor side, over extrapolation. So that's maybe a category that I'm a bit more have my doubts on. There are other things that I think are interesting, that are still interesting that are coming out of the big tech firms. And for example, things around developer ergonomics. I think often the inspiration should come from the big tech companies because they're just the first ones to like really care enough about the experience of their developers to build out certain solutions. Often in order to actually make those types of tools useful for the world, you have to re-architect them, make them a little bit more friendly and general purpose, etc. But like a lot of the inspiration can still come from there. And then to your point, I guess there's also like maybe a fourth category of things, which are just types of technical problems that you would not encounter if you weren't at the technical edge of innovation. And maybe that's like really large solutions that just do hyperparameter optimization, or honestly, sometimes it's a technology, sometimes it's about the degree to which the system is bespoke, but we can get more into it. I wouldn't lump vector databases into that. We can do that, but that's the answer.
So I think what you're saying is everybody tried to build Google for a long time, and we're beginning to figure out the world only really needs one Google. Is that fair?
I think also there was a period where a lot of other websites and companies in the world did hit Google scale, like up to Google 2004. And then I think like Google 2015, rarely anybody actually hits anymore.
Just to play devil's advocate a little here. So very rarely do people need Kubernetes, right? But now, interestingly, like there's very few companies in the world that actually need it at that scale. Interesting part is that when I worked for a startup, I was a founding engineer there, and I wrote the first iteration of Infra. We're using container orchestration when there's like barely any user. And I'm seeing this across the board to everyone, like in all the companies, SMB. We don't need that, but it's so easy to get started. We're just going to use this battle-tested tech from the very beginning and then deal with it later. How do you think about that?
Just because you tricked everybody into buying into something to the degree and point where there are robust solutions that are ready for people to pick up doesn't mean it's actually what they should be doing in 5 years. That's once everybody buys into something, sure, you'll develop robust tools. Also, actually, I think it's a great example of how powerful network effects are in infrastructure and among developers, right? Like you might have something that everybody at a certain point in time knows is suboptimal. But if 5 of your friends that you can actually ask for advice and how to work with something and how to set it up or have done it before have used it, you'll go for it. Like I have friends at the large, I've been spending a lot of time talking to folks at the large language labs, and I won't name frameworks, but there are certain technologies that they use where I'm like, you're using that, you're like the cutting edge of AI, NLP work, whatever, this 12-year-old technology. And they're like, yes, but when there's a bug, I can find docs and I can find examples, and there's a really robust community. So anyways, that's my take. And I'm excited for what comes next.
I'll just blame the VCs because you're sitting there trying to get funded, and some guy who knows nothing about technology or is just vaguely tuning in goes, did you build this on Kubernetes? And you go, yes. And they go, oh, okay, we'll fund you. And I think there is it was a buzzword that also said, oh, we're ready to scale and we're going to be the next Google. And that worked for a whole bunch of other things wrapped up in that strange funding world where we're all going to be Google. And of course, we couldn't just build a nice sized little company that's worth a couple $100 million. It must be worth billions. So whatever.
Yeah. Interesting enough, I'm actually like usually the first one to jump to like bash on VCs, but actually in this case, I believe that it's actually the developers who are at fault, and not the developers, let's say the actual broader kind of market forces. That we live in an unfortunate reality that hype-driven development is a thing. Let's say this is the argument I always made to my peers. I was a VP engineering at Salesforce, ran a team of a few hundreds of engineers. And the unfortunate truth is if there are 2 candidates that show up and you ask them about some project that they did, and one of them will say, I just used like Heroku and MySQL database and just wrote a simple script and solved the problem, versus someone else that says, well, I had a Kafka cluster that was running on Kubernetes and it was using all of this stuff. But unfortunately, in most cases, the second one will get the job because they would be considered the more professional engineer and all that. And to be honest, that just makes me sad. But yeah, that's a reality.
But another thing you brought up, this is really interesting point, because like what I'm hearing is at the end of the day, there's a portability of skills. And where does that come from? That comes from market standardization. Oh, we Terraform. Do you need Terraform? Eval. ClickHop's probably work for you if you like provision 2 things. But at the same time, Kubernetes, there's actually a documentary about Kubernetes. It's a very good one. Go watch it. But for Kubernetes, it's so interesting. At first, it was like, oh, Google are using it. I came out of Borg. But then it's such a good abstraction. I'm not saying it's perfect, but it's better than what it used to be before. That it came out, the market all agree, oh, okay, this is a standardization that we can align on. So hence the ecosystem, hence more and more people know how to do it because more and more people know how to do it. Startups want to hire people who know how to operate it to get started easily. So I wonder how much like the flying wheel of having the hype-driven technology, but people realize that, oh, we can actually have a thing to align on, market agree with it, and have people working on it, and people know how to operate it. Now you can only hire people who know how to operate it.
Everyone talks about S-curves, but that the dynamic you describe of knows how to use it is exactly why S-curves. The driver of an S-curve is not some external physics force. It's just people talking to each other. And at some point you get to everybody knows how to use it, so we use it. That's why certain countries drive in the left and certain countries drive in the right, or we're still stuck with Microsoft Office. Because then all these things are struggling to cross that chasm and get across it. And there's that beautiful moment where it takes off, or it's a horrible moment because it's actually an awful tool, but it stops mattering. Or why did all teenage girls X years ago start wearing really ugly Australian sheepskin Ugg boots? I have no idea, but Kubernetes is really no different than Ugg boots.
The analogy for this one and cloud, and two is the second one is Kubernetes.
Yeah, I think that's a great substitute for analysis. But
Yeah, I think maybe we can come up with a sticker here. Kubernetes, the Ugg boots of Infra.
Amazing, and they're attributed to Steve. I can draw a comic on this.
Yeah, that's great.
Ugg boots in winter is one thing, but like Ugg boots in LA, I didn't get it. I just don't get it.
Kubernetes blast.
All right. I'm upset.
So we talked about this hybrid development, and by the way, like this whole kind of engineering product is a space where I spend my days now. And one of the seminal points that came out there around 2015, it was by Kellen Elliott McRae, who I think was the CTO of Etsy. I hope I get it right. And he basically coined a phrase of choose boring technology. And he came up with a concept, or maybe it was Matt Ricard, of what he'd call innovation tokens. And basically the idea there was that you should think about engineering as a business and then think about what actually is core to your business. What are the things that will make you win? And what are the things that you just need to do because you just need to do them? And therefore, what he suggested is maybe you choose like 3 new technologies a year or something like that, but like basically have a quota or a budget for innovative technology and choose it wisely. But for everything else, just choose the most boring solution possible, exactly because these are the battle tested, the easier to maintain.
I think that's wise for everyday things and probably the best advice for most engineers and developers out there in the world. I will say I do get surprised and impressed how strong of a correlation there is, though, among startups and technologists in Silicon Valley that are pushing the limit in their applied area and also still use technology that is pushing the limit from an infra perspective. There is a really strong correlation, and I don't totally know why. Maybe it's more of a personality type thing. With that said, I think it's horrible advice for 90% of the world. But I often go look at what's like the coolest new consumer thing using under the hood, and it tends to be the coolest new infrastructure.
Gaming companies are best at innovating our infrastructure.
I think it's maybe something just biological to us that we have to feel special. So like it's not enough for us to feel special in one field. So we have to have a special infra, a special app layer, and then a special go-to-market, a special kind of pricing model. Everything has to be, because obviously we're unique. We're the startup that was just started. And obviously the world has never seen anything like us. So we have to innovate anywhere.
Yeah, no. And what I keep in mind, I ran across it in a completely different context, is somewhere in Pennsylvania is the largest manufacturer of frozen pierogies in the United States. And that person has an IT department. And pierogies are little dumpling things that don't necessarily, unless you're Eastern European, they're not in your world. That is the other end of that S-curve tail. And I do feel like, and that's where I actually get excited about some of these framework things, where I also feel like it gets missed in the dialogue, is that's your mass market adopter, and how do you reach them? As opposed to this kind of strange internal dialogue where people are just churning the sexiest new tool and it never really takes off. Just an observation.
And when it comes to bottom of market, top of market, the other thing to note here is there are more and more, it's not just about what use cases can you serve, but I think the market is expanding for what some investors call SMB tech. There are more and more mom and pop shops willing to spend $100, $200 a month on their tech stack. And when I say more and more, we're that there are entire indexes and kind of rankings out there if you just search SMB tech index or list. And I think we're going to see more and more public scale companies in the next 10, 20 years with average contract values of stub $1,000 a year, which sounds absurd, but then hundreds of thousands of customers, because software is in the world and everybody's becoming a software consumer and everybody is building with software. So that's the other side here. Like you could potentially not even go that much further up the curve in terms of what kind of use cases you can deliver. There's also just growth within the bottom of the distribution itself.
Rajko, are you allowed to say software is eating the world?
I don't know if there's a trademark on it or that.
No, I'm saying, isn't it frowned upon in the specific part of Menlo Park where you sit right now, that if someone walks by and hears you like saying, hey, do we have a spy here in our offices?
We're all friendly in this neighborhood. And also, like, some things doesn't come true. Yeah, the number of blog posts I've seen start with, as people say, software is in the world, but really, machine learning is. Anyways, yeah, so AI is. So yeah, that's why I said it with a tone, make it clear.
Yeah, so maybe as we wrap this thing up, each one of you can share some item you read recently that you would like to recommend to the listeners.
This is the easy answer because I recommended books in the Yeg channel, but the book I'm still reading, The Weirdest People in the World. It's a very good book. So the whole thesis is that how the Western world start to learn about how to collaborate with other people when they're not in your immediate family. And that turns out to be revolutionary. It's a very thick book, but it's like a very calm read. So it's a perfect one to pick up.
Yeah, that's a good one. I was as a blog post, this I'm all in on server side SQLite by a guy who went to join fly.io. I keep coming back to it, and it rings true on it's a really well written post, but it also rings true on a lot of the other themes about, hey, look, everything doesn't have to be a Google. The only other thing I would really recommend, especially in this time, is everyone says the word disruptive technology and then they nod their heads, and no one has read Clayton Christensen's Innovator's Dilemma or any of the articles around it in a really long time. I will guarantee you that if you haven't, your understanding of the phrase disruptive technology and the reality of the phrase disruptive technology are totally different. And it's this theme of simple, cheap, easy, at some point just utterly destroys top of market, super optimized. And it doesn't happen the way people think, and it's not nearly as fun as people think, and it doesn't happen as often as that phrase gets used, but it's an incredibly powerful tool to look at the world. So those would be my two.
On my end, I'll go one recent one actually from Yeg, the semiconductor analysis on discussing whether or not NVIDIA is losing its monopoly over the kind of GPU kernel programming market with CUDA. I think it's super interesting, highly controversial. I don't think it's settled yet, but that's a cool one. There was a whole wave of companies and folks that tried to compete with NVIDIA in the last 6 to 8 years, and it didn't really work out, but there might be a new opening there. And then the other one, and yeah, I think it's also funny, like there are 3 new blog posts on large language, on a kind of AI every day. One that I would single out, Davis Tribe, it's called The Biggest Bottleneck for Large Language Model Startups is UX. And it's one of the better ones in terms of really giving concrete examples, screenshots, tricks you can do to improve the UI and UX experience for people developing applications on top of LLM. So I would say that's a good one to go check out.
Awesome. Yoko, Rajko, and Steve, thank you so much for joining us today, and for all the listeners, thank you for being a part of it, and see you next time.